behind the scenes. Hey, we're live. Welcome to Engineering Design in Omniverse. Jen and I are hanging out, and I've got something cool to show everyone here in just.
And it's not the Ames chair?
Second. What's that?
It's not the Ames chair?
It's not the Ames chair. That is a cool thing, but no, it's not the Ames chair. It's another cool thing. Let's see here. Are you ready?
I'm ready.
This is a TT02 car I'm building.
Nice. Wait, is that all 3D printed?
No. I just bought it at the hobby shop.
Ooh.
Got a good price. It was like $117, so less than I expected from what I'd read.
For the whole package?
What's that?
For the whole package?
It doesn't have the receiver controller combo, and it didn't come with a battery. But I already had those because a few months ago I was going to design and build this whole thing from scratch. And now, instead of doing the whole thing from scratch, we're using this platform that already exists, which I think is, it's a little smarter. It's working smarter, not harder, right? To go ahead and use an existing car if you can. And as I've been going, let me share my screen. As I've been going, I've been weighing parts and measuring stuff. And so I'm taking some of these are just all measurements off. I'm taking off of the suspension arms on this side. And then any parts, so I'm bolting stuff to the chassis right now. And so any parts that move independently from each other, we want to weigh those so that when we bring them into Omniverse, we can put accurate weights in. And so I'm just weighing all the stuff except for, stuff that's rigidly attached to the chassis. I'm not weighing yet. Once we have everything on the chassis that will go onto the chassis, then I will weigh the chassis. And I'll subtract the weights of all these arms and stuff from that weight to come up with our chassis weight. Yeah. This is for Jen. Checklist for today. 1, coffee. End of checklist.
I mean, you're not wrong. I'm still waiting for this coffee extension that y'all keep talking about, and it's not here. Like, where is it? Oh, and then Zia has added to the checklist more coffee.
Yeah. So yeah, we got the here's the TT02 I'm building. That's going to be this is our platform, the real life version. And then on this other screen, let me pop this up. I've also been working on CAD a little bit. So here is the suspension template I've made. And you can see, like, if we zoom in, this is the inboard upper suspension mount. Here's the outboard mount. For the lower suspension, here's the inboard mount. There's the outboard mount. Here's that's the rear suspension. Sorry. Let's look at the front. Same thing though. Inboard mount, outboard upper, inboard lower, outboard lower. Steering is right here, the steering points. And then right here to here, that's the front shock. So I'm getting all these suspension hard points in there. Yeah. Oh, great. So a couple of good questions rolling in. One, did you measure all these out? No, we're just establishing the pipeline. So these, I just took wild guesses. Well, not wild guesses, but reasonable looking guesses. I knew the wheelbase of the actual car. It's like a 257 or 357 millimeters. So I started from that. So I guessed at the track width and all these suspension points, but put them in kind of the right places. And then now as I build it, I'm writing down all the measurements I should need to dial all those in. within a millimeter. It's tough, like sometimes I'm like, I've got my, nice calipers, and then I take the arm and I'm like, well, let's see here. What's the offset in this direction? And you're just kind of making your best eyeball guess. So if you're expecting some really accurate measurements, we're not there yet. And here's another great question. Can we have access to the CAD? Yeah. So let's first of all, let me get the link. I'm going to share a link to view this right now. And we're using Onshape. The reason we're using Onshape, I like all CADs, right? I love them all. They're all great in their own, have their own strengths and weaknesses. One of the strengths of Onshape is that it has a free tier for open source projects. So if your project is open source, you can use their free tier. And so that way you all can view it. And if you'd like to contribute, let me share our Discord link real quick. Where is that? Just a second here. I've got a link here. Here we go. I'm going to share a link to Discord. So here's the link to Discord for everyone. And then you want to look for hashtag JetRacer is the channel for this project. And there's a thread in that channel where you can go ahead and ping me. So you ping me that you want access to edit. And then you'll need to private message me your email address, and I'll add you as a contributor. And we'll talk a little bit about how each of you can contribute. I want to come up with a task or two and make just 1 or 2 task assignments with CAD. So if you're interested in CAD, then I'd like to give you some assignments, okay?
And how can they reach you on Discord?
Oh, if you hop into that JetRacer channel on Discord, and I go by Strainflow on Discord, and you will find me there. I've been posting a lot. Yeah, at Strainflow. That's me. Good questions. All right, so we've got this CAD template, right, with the suspension hardpoints. And then what else do we got? I just did some wheels so it looks like a car. Took these wheels off of dimensions from the vehicle. And then as I'm building this, I'm taking the weights of things and recording the weights of any moving parts. So for example, any parts that move relative to each other. For example, in these arms, I don't know if you can see very well, but there's a little spherical bearing right there. And I've weighed the arm and the spherical bearing separately because they move separately from each other. And really that spherical bearing, when we assemble, if we want to be really good with our kinematics, that's going to be attached to the wheel uprights, not to the arm. Even though when you like build the car, you pop that bearing into the arm, it moves with the wheel assembly and with the uprights, not with the arm, right? So it's good to kind of think about that as you go. All right.
Are you also thinking about the material? I know you have like the part number, description, and a mass. Are you also going to have like a section for what kind of material it's made out of?
That's a really common field in bill of materials. I'm not worrying about that yet because I think it'll be pretty easy to go in and figure that out later if we need to. And in particular, you can just kind of look at them, I think, after the fact and add that column later. The hard part about some of these dimensions is once the car is completely assembled, it would be pretty hard to figure out the mass of this arm. Or along the same lines, it'd be hard to get calipers in there and measure some of these offsets. I mean, as quick and dirty as some of my length measurements are right now, it would be way worse if we assembled the car completely first.
Mm-hmm. Okay.
And let's see here. What determines the orientation of the suspension points? Do you mean these in CAD? If you're talking about these connectors, I have set that orientation. This blue is the primary axis, and I have made that forward and back for all of these suspension arm points because the primary axis of the joints is forward and back right there. So that's why I've done that. Great question. And then Papa Check says, this is probably the coolest educational project for going from real to sim. Thank you. I'm really excited about this because this is just our first robot and we're just going for accessibility and affordability. But after this, there are lots of cool robots we could do. And one I would be really interested in doing, we're doing a project with basically building a robotic cell. And I wonder if we could, you look at the cost today of adding an automated robotic cell to a manufacturing facility. And I wonder if we could use Omniverse to dramatically lower the cost of entry for robotic automation. Oh, so we have a question. I think basically Zia is saying, what is a robotic cell? I'm going to Google it here. And let's come up with a picture. Here we go. This would be a robotic cell in manufacturing. So you've got this area. It's enclosed. It can be typically enclosed for safety, so you don't have to worry about hitting people. And and how much do you think it would cost to add a robotic cell to your floor right now? I don't even know. Probably a lot. But I wonder if we could train, if we could build some Isaac Sim plugins, if we could come up with some pipelines, if we could come up with some training methods in Omniverse, I bet we could really lower that cost. And that's absolutely right. That is the thing that Adam showed. And that's a big deal in automated manufacturing, especially in the automotive industry. And here we go. Lots of questions rolling in and interest. The objective is here to build a digital twin of JetRacer. Will the JetRacer send the data to Omniverse? That's not currently on the roadmap. I think the objective of this project is to get the JetRacer asset rigged in Isaac Sim so that you all can use it for whatever activities you would like. And I think adding telemetry so that the JetRacer is a true digital twin would be a really cool project. And by the way, my goal here is to facilitate all of you in starting an Omniverse-based business, right? That's the goal. Because I've got people like Hypercraft. Let me show you Hypercraft. I don't know if I've done that yet. Okay, let's look up Hypercraft real quick. Okay, Hypercraft, they've been working with Sierra Cars. This is just one example, and we could find thousands of examples this size for this size of company. And Hypercraft is an electrified drivetrain startup. Okay. And so they manufacture battery packs and electric drivetrains. And they're a scrappy startup right now, but they're well funded and aim to be a large company someday. Well, they've got to make that jump from small production quantity, kind of more customized drivetrains to larger and larger up until mass-produced drivetrains, right? Well, if if we can figure out some pipelines and some processes that would help them with their manufacturing using Omniverse, then you all could start to write custom apps, start to sell services. I mean, you wouldn't even need to sell the app. If you can develop a pipeline to train a robot for, easier or faster or for less money than without Omniverse, then you can just train robots for people to do tasks in their manufacturing facilities. That's absolutely a viable business. Okay. And so, yeah, I am trying to make you all entrepreneurs because Omniverse is so cool. I want that to be your job. And because I can't imagine that the job you've got now is cooler than working with Omniverse every day. So I love it. Anyway, let's see here. More questions. Let me read through these. SLAM. I don't know what the acronym stands for, but it's a robotics thing.
Zia responded to that. It was
simultaneous localization and mapping. Oh, did he answer? Oh,
yeah,
sure enough,
localization and mapping.
Yeah. So it's a really common, and I don't understand robotics very well myself, but I see that popping up a lot with robotics. Mm-hmm. So let's learn what it is together, and let's all get paid. That's right. I want all of you to get paid for working with Omniverse, and I think one of the first steps is, we've got customers like Hypercraft, okay, and we want to build some workflows so that you all have something to sell to companies that size, okay? Mm-hmm. Because there are a lot of, it would be hard for one of us individuals to go into a BMW or a Mercedes and sell them some services, right? They have their established supply chain and that sort of thing, mm-hmm. typically, right? But I think absolutely one of you could reach out to a Hypercraft-sized company and listen to what they need and then help them come up with a pipeline or workflow that's a true win-win, right? And this is what we're going for. If you can save a company $2,000, charging them $1,000 to do that is a clear win, right? They're going to want to do that. So that's the kind of thing we're going for, is these clear wins, okay? And if you can make that sale 100 times a year, you're making enough money to make it a business, right? So mm-hmm. that's the idea.
And it seems like I got a couple fans in here, so I'll give some more ideas if you guys aren't too interested in automotive. When I went to Portland, was it early this year? It was sometime. I went to Portland, and my friend was showing me this coffee machine. And I didn't believe her. I was like, what are you talking about? And there's this company, I think they're called Artly. So it's like Art and then LY. And they make robots, like this robot arm that basically makes coffee for you. And it's pretty amazing. Like they can make a latte, they can make a cappuccino. So, if you wanted to, recreate that in a digital twin and reach out to them, because it didn't seem like that they were like a big company, because it was like a small thing inside of a larger shopping area. That's one of them. Or you could reach out to Duck Donuts about their process on how they make donuts, because I know they have machines that do that, and you can make a digital twin of that, and then you can get more maple bacon donuts.
There we go. Now we're talking. Yeah. Couple more here. Bird Aid says that's really cool. You built a Lego RC car in Blender. That's awesome. Yeah, you can absolutely bring that into Omniverse, and you can also there's this Bricklink Studio CAD app you can use to build Lego stuff, and then bring it into Omniverse from there, which is pretty cool. But we're going to be going over how to rig cars in Omniverse. So I think, stick with us in these live streams, and I'm not sure how many it will take us to get there, but we're going to have this. I think the next step is to what I would call rolling chassis. We're just going to get this car defined enough and imported into Omniverse, rigged up with joints so that we can just kind of pull on it and roll it around. And I actually have another rolling chassis I did for an RC car I'll show early on. I just did it with that kind of custom one I was making from scratch, and we're switching to this other platform. I also learned a few things when I was doing that, so I think I can do a better job this time. So, but I'll show you what I mean here. All right, great questions. What else we got? Yeah, I think the rest is just silly banter from you guys. So, all right. So let's take a look at this. And first, I want to give just some tasks out. So if you are interested in helping with the CAD, this is what I need help with. Let me see here. So I'm going to show you a workflow. All right. Oh, excuse me. This is in Onshape specifically. Okay, we've got the suspension template here, right? It's got all of these hard points. Cool. Let's see here. Let's create a part. And I forget how to do this. So derived. There's a way that we can make a new part studio that's derived from this one. And that's what I'm trying to remember how to do. Sheet metal. Let's see here. Let's actually, if I create a part studio, I think they might have changed their stuff. If I make it derived from the suspension template, what I've done is I've created this part studio, and let's rename it to rear, lower, rear. Actually, we'll say front, lower, arm. That's the name of this studio. And I can tell the front because it's got the steering in it. I'm a little lost right now. You know, the planes aren't labeled the way I like, so I hope it doesn't bother you too bad. I like X to be front and back. Okay, so up here, we want to just make like a little fake A-arm that goes from this suspension point to this suspension point. So let's see if we can do that. 3-point. Let's see here. Let's see if we can do it. I'm going to go here, here. Okay. Yeah. Oh, we need a 3rd point, don't we? Let's see here. We want the axis to go forward and back. And so what I'm doing here, oh, I wonder if I can do like a plane through an axis or something like that. Line, angle. I want like a, oh, here we go, plane point. Let's try that. Let's see how it looks. Oh, that's going to be my plane. Huh? I turned those all sideways, and so now they're all... you could do a sketch right on one of these. And that's one way you can do your sketch. I wonder if I can do this. Oh, yeah. Let's make a... kind of figuring this out as we go. So... I cannot pick this as an origin entity, it looks like. Okay. On entity between entities. No. Okay. So basically what we're trying to do here Oh, you know what we should do? Let's just do this. Sketch. We're going to make a point. Oh, I didn't do it right. Let's make a point right here. Okay, so we got a point there. Let's make a point on this other one. Same way. We're going to make a sketch right here and make a point. This is our second point. And then I need to create a point or a line that's, see, if I'm used to CATIA where I have 3D geometry, I can just make a point in space, or I can make a line from this point in this direction. I don't know how to do that yet, but I bet what I could do, let's make our sketch plane, make a make connector. Now I can probably select that. I can't. Why not? Oh, bummer. Okay, let's try this again. Let's see what my plane options are. We can do offset, a plane and a point, a line and an angle, a point and a normal, 3-point mid-plane curve and point. No. The problem is right now these are level, and so I could just like put this plane level with that. But what I want to do is build a plane from here to here, you know. I think what I could do, I've got my parameter studios here. So I've got my inboard suspension geometry, right? These are all of my parameters I use to make these suspension points. So what I'm going to do is make a make connector right here. And if I realign it, for the primary axis, we want it to be, oh, the top. What I learned is that'll snap it to this top plane for the owner part. Great. Now we can move it, and we're going to move it the inboard front lower X, inboard front lower Y, inboard front lower Z. That's going to put it right on top of this other one. Oh, I'm on the wrong side. I'll have to redo those points anyway. Or actually, I won't. But now what we want to do is just take the X, I don't know, minus 20. Oh, can I do that? Just figuring out how to do the equation here.
I see 2 questions. Number 1, is OnShape a DCC SAS?
Let's see. Oh, a bunch of, yeah. It is direct content creation, and I suppose it is software as a service because it's available through the web. So I suppose yes.
Mm-hmm. And number 2 is, does the software you use matter in order for you to create assets for sim, because CAD software are hard?
I would say if you want to simulate robots, I would get into CAD. CAD is tough, but eventually you're going to want the kind of the engineering level of accuracy. It's hard because it's so accurate, right? And I'm not sure why it's This can be any number. So I'm just going to make it 100. All right, so let's see here. I don't need these sketches anymore. And then there's another question is, let's see. All right, let's see. Somebody asked why we picked this one. Why are we using Onshape over other CAD softwares? It's because it has that free tier. So you can use it for free. That's it. I'm not commenting on any of the other strengths or weaknesses of it as a CAD software. Papa Check is saying that the CAD does matter. It does. I mean, I would say there are CAD softwares that won't do well enough for you. There are a lot that are good enough for what we're doing, and that's Onshape, SolidWorks, Inventor, Solid Edge. Any of these kind of commercial ones are going to be good enough for what we need to do. If you were going to work directly with a large automotive or aerospace supplier, you would want to get into NX or CATIA or PTC, Creo, one of those bigger ones. Yeah, Fusion 360 is one from Autodesk. It's a little bit more small. I would say that's more at the maker level typically. Small business would be using more like Autodesk Inventor or Autodesk Inventor or SolidWorks. SolidWorks is the largest market share for that tier. CATIA and NX are both large market share for that aerospace and automotive prime supplier tier. Let's see what else we got. Yeah, let's get this sketch. Let's get this sketch made. So now that I've got 3 points, all I did was I just made a plane here. So I've got suspension. I just made this fake one here just so I'd have a plane to work with. So now we can create actually, we can make a plane from here. Actually, we want to go 3 points. That one. And I'm a little lost. Just a second. That's my steering arm. That's my shock. There we go. So I took those 3 lower arm points. There we go. And I made a plane on them. This way, by doing it that way, if later on in the template we move these hard points around, that plane and that sketch will move with it automatically. They're linked. So that's parametric. And now what we can do is we can pop a sketch onto this plane. Oh dear. We want plane 1. Okay, so now that we have that sketch, we can just go like this. This does not have to be high fidelity. And all I've done here is make a basic control arm. So now we're going to exit this sketch. We've got our curves. We're going to sweep it. Let's see how well that works. Face it. Oh, just a second. What we want to do, let's actually look into the sketch again. We want to delete this line here, I think. There we go. And next, what we'll do is we're going to make a plane on the end of this line. We'll do point normal. So pick this point and this normal. Okay. So now I can do a sketch there. Oh, I just ended the sketch. Here we are. We'll do a little circle. Let's make it like 5 mil. We can put a dimension onto it right here. Let's make it like 5 millimeters. Oops. Actually, some of the stuff on there is 7 millimeters, so. Oh, I messed something up here. 7 mil, because why not? So now what we can do is we can go to this sweep function, select that profile, and select this. Select that path, select that one. Done. Okay, so now we have just like a basic physical representation of the control arm. So let's we'll say this control arm profile. Oh no, this is the path. We'll name this the same thing. Doesn't mind as long as they're different things, I think. Rename control arm profile. Control arm. There we go. Rename control arm solid. And you'll see, by the way, that it now shows up as a part in this part studio. So what we can do is we can mirror that. Entities to mirror is part 1. The mirror plane is this. Let's see here. This plane. And we want to say new. That'll make us a new part. And so now we have a right and a left. Left. Let's say lower, front, left, arm. Rename lower, front, right arm. You can also, this is a good way to do it, you can select these two, right click, and you can say add selection to folder. Call it like path. Now we can say like, just call it like plane. Sketch. I might organize it this way. Call it profile. Plane. What do I call this one? I guess we can just call it sketch. That's fine. You know, there we go. Let's see. Let's go back. Yeah, good call on the organization. You know, I found that if you do some Googling, there's quite a few pop up. So it hasn't been too hard to find tutorials, to be honest. So I'm not too worried about that. Alrighty. So now we've got a right and left arm. So we can go into the full vehicle. We can say insert, and we can insert that and that. And the cool thing is we've built our origin. So we're going to do this for all of our parts. We're going to put our origin at the same place for all of our parts whenever possible. The reason is, well, if they're unique. With the wheels, I haven't done that, but for these arms, we want to do that because it's going to make it easier to make these suspension hard points that we do. We've got to that'll come into play on the Omniverse side. Right now, we're just kind of coming up with these cartoony solids. They're basic. And just so that we're going to bring these into Omniverse, we're going to rig it, and then we can get it driving and have something we can drive around. And then later, as people who are more interested in CAD can go in and make better models and meshes for this, and we can import those, and we can get a better looking stuff as we go. Yeah, the origin is at 0 for all the parts. Okay, great. So let's see here. Let's just try. Should we just try the Onshape connector and see how well it works? Let's just see that. So.
Yeah, why not? Show off a connector. Show it off.
All right. So to do that, I've already got Isaac Sim open. I can go to Window, Extensions, and we're going to search for Onshape right in here. Onshape importer. Great. Oh, it's already enabled. And I just don't know where to launch that. Let's see if it says. Oh, there's documentation. If I say file, oh, right there, import from Onshape. Easy peasy. Okay, just authorized Onshape right here. Let's see if we can find JetRacer. Bug. Oh, it's not showing up for some reason. Let's see. There was a problem there. Let's find out. Let's go back home to Onshape. You know what? It's only showing the stuff here in my home. And I made this folder for JetRacer. So I wonder if we can move it. Move to just right here. Move here. Okay, so now if we go home, there's nothing in JetRacer. It's right here on the main. Let's see if that fixes that problem. Oh, you know what? It's already loaded it. Oh, okay. We're going to relaunch Isaac, I guess. Or no, let's do the extension. So close this. Window, extensions. Let's relaunch this extension and see if it'll show up then. Yeah, it looks like the Onshape connector does not support folders. We'll see. I haven't gotten it to show up yet. Zia, did you just +1 yourself? Is that allowed?
No.
You're not allowed to do that. You're not allowed to +1 yourself. All right. Sure thing, man. Whatever. Trying to get it's like liking your own LinkedIn post first. That's not cool. Yeah, I wonder if it's already got that stuff saved. I'm just going to relaunch Isaac and see what happens. Because JetRacer's right there. Come on. It's in assembly. It can only, yeah, because I know that the importer can only import assemblies, but I've got one right there. Full vehicle. Isaac is relaunching in another window. Come on. It's almost there. There we go. File, import from Onshape. Okay, it's re-authenticated. Come on. All right. Well, I wonder if it takes a minute. Oh, no, that's for things to kind of propagate through that system. If I go to public documents, there's lots of stuff in here. Less, because it's public too, right? Oh, look at this. Somebody else has got some JetRacer stuff. That's kind of cool. JetRacer housing. What's this? Don't even know. That's kind of cool, huh? But let's go back to my stuff, I guess. And I don't know why it's not showing up yet, but I'll dig into that a little bit. Figure out why not. We'll get there. For now, let's see. Let's just export it in. Let's see what the export options are. Export. Step. Yeah, so we can just do like I think a step file would work great. Okay, there it is. It's going to be my downloads, I bet. So we can just go to File, Import. Let's make sure step is in the list. There it is. Let's go to my downloads. Full vehicle.step. Let's get in there. There it is. So it's really not that hard to import, even without the connector. The nice thing about the connector is if you have the right kinds of joints, I think Revolute joints are what it supports. It will even import your joints from Onshape. Unfortunately, in my experience, at least it didn't used to support spherical joints, so it doesn't really work for cars. It works better for your typical robots. So it won't work for Ackerman steering robots that have spherical joints. It would work for probably for like a JetBot or for what has the differential control style, or will work for robotic arms and stuff. But what we'll do next time is we'll start to get into, we'll create a layer and we'll start to rig up the vehicle in a layer. And the idea here is that we should be able to, is if we keep our, if we keep this vehicle the same structure, what we can do is we can make an edit layer where we take all these items and put them where we want them to be. And then whenever we import this vehicle and apply that layer, it will redo all those changes for us. So the way to think of those edit layers, I would think of them more as workflow or more as like a macro than thinking of them. I used to think of them as hierarchy, but no, think of them more as like a macro. And so we'll rig this vehicle using an edit layer so that every time we export from this assembly, we apply that edit layer and it will apply all of our rigging over again to whatever assembly we export. It's really cool how it works once you get the hang of it. For now, let's go ahead and do the front upper arm real quick because it was a little bit bumbly how I did it. I was kind of getting the hang of the environment a little bit. Let's do that front one. And then I'm looking for volunteers to do the rear arms. Let's just start with that. I need a volunteer to do the rear arms and the steering link. Just cylinders like this. So let's see here. Let's do this upper arm so I can show you how that works. We have this, where are you? Front lower arm. We made that one. I'm going to go ahead and make a folder. Call it arms. It's right there. And then we're going to make a new part studio. We're going to rename it front upper. Name it here. Front upper arms. We're going to put that into the. Actually, I'm going to rename this like suspension, so that tire can go there too. Oh, I don't know. Can you duplicate? Copy to clipboard. Duplicate. Oh yeah, you totally could. But this front upper arm is now empty. Let's go ahead and bring in that suspension template as our base. Oh, and by the way, we can hide this. There's this derived stuff. We can hide it if we want. But anyway. And now he's got the arms by themselves. So let's come back here. Let's find that front. It's in the positive X direction. Okay, so our upper arm. These have names in the suspension template. Let me show you that real quick. If we go to suspension template, we're looking for the inboard. So here's your front upper inboard. Here's your outboard suspension. Here's your front upper outboard. So you can look at the suspension template if you've got questions about what's what. Let's look at that front upper arm again. We're going to create another mate connector. We'll put it at the origin of the part. We'll realign it, the primary axis, with the top plane. That's going to attach it to the top plane because all of these mate connectors have to have an owner in Onshape. And for some reason, you can't just select that top plane interactively. And then we're going to move it, and we're going to say these parameters already exist, so you can just say inboard, front, upper, X. Inboard, front, upper Y. Inboard, front, upper Z. And that's going to make one right on top of that inner mount. We want to just take this down to just any number in the X. That's going to make it planar. That's going to make it collinear with that suspension mount, which works for us for now. Okay, great. We've made that extra mate connector. So now we can create a plane by 3 points. We're going to select this one, and where's that upper one? This one. Notice this plane is angled, but because they built it off those mate connectors and off those parameters, so check this out. If I open up my variables, I'm using this. I can insert these global studios. Here's my outboard one. So check it out. Outboard front upper Z. Let's make that like 70. It's going to update. Do you see that? It updated our suspension template. That propagated all the way through this plane because it's built off of that point. There it goes. We just put it back. This way, when I measure the actual positions of those hard points and put those positions into that table, all of these mate connectors will move to the right places. All these planes will adjust. Everything you built in sketches on those planes will move with them. Okay? Yeah, it's all parametric modeling. Cool. So let's go ahead and build. Let's go ahead and build the what's it called? Not the profile, but the path. And for that, we'll just say from here, let's go to here again. And we're going to go from here to here. Let's see if we can make this point coincident with that axis. We can't. So we're going to go, we'll do, oh, I did it wrong. Did I cancel? I did. My bad. Let's go again. We're going to go select this plane again. We'll do a line. I think this is the easiest way to do these arms. We'll go from here to here to from here to here, and then to here. And then what we'll do, select this and make it a construction line. Where's that option? It's in here somewhere. Maybe I right click on it. Construction. There we go. Then it won't come out of the sketch. Cool. We've got our path. Let's do our profile. For the profile, we'll make a plane. And we'll say point normal. Select this point and select this curve as the normal. And we're going to make a sketch on that plane. And we'll just make a little 7mm circle on that. On this end right here. We'll dimension it to 7mm. And we're done with that one. We'll do a sweep. So here's our profile and here's our path. Here's our other path. Check. We could say this left, or let's see, we'll say front upper left arm. And we'll mirror that. And for the plane, we will select this front plane. Gives us our right. And we'll say rename front upper right arm. Cool. So we've made the geometry now. Let's go back to our full vehicle. And we will insert We got the front upper arms now. And yeah, there you go. So now we got
And
front
that's
upper arms.
all they get.
We're out of time. Yep. So my question is, who is going to pick up and do some rear arms for us? Well, let's hop on a Discord. I'm looking for a volunteer for that. Who will do? I need someone to do the arms. I need someone to do the tie rods, and someone to do the shocks. The shocks are a little different because you'll make an upper and a lower shock, but both of them will be cylinders that go from the lower shock point to the upper shock point. They'll just be kind of offset. So need someone to take on those tasks, or I'm hoping someone will. I can do it if we need to, but I really want some of you all to get involved. So let me know on Discord, and I've got to hop into a meeting, so I've got to go right now. But it's been a pleasure, and we'll see y'all next week, where if someone will help us model these parts, we can rig this up with joints and simulate it. It'd be really cool. See y'all later.